Hey everybody, this is Larry. It's November 6th, or well, it is November 6th here. Daylight saving is kind of weird for me. So yeah, today we're going to do a bonus question that I haven't done before, hopefully. So yeah, hit the like button, hit the subscribe button, join me in Discord. Let me know what you think about this poem. Also, I'm going to, I don't know, I wouldn't say a contest. Can you see it? Okay, so yeah, I'm trying to name my plant. So definitely give it some love. Let me know in the comments what you think, Larry's plant can be named or whatever. So yeah, let's do a hard one. It's Sunday. I have some whatever. So yeah. Okay. So let's spin. Yeah. Okay. Good. Oh. 940 distinct subsequences 2 hard. Let's get started. I think this one is kind of n is 2000 is always a little bit tricky for Python. So we'll see if this actually times out. But otherwise it should be okay. And I forgot the mod a couple of times, so let's actually do the mod. Right. I mean, this is a way whatchamacallit, I wouldn't say standard, but something that comes up a lot. So but let's see which one. Distinct noms. Okay. So oh wait, I thought this is the one where you have two sequences and then you count the number of whatever. So that's not that. Okay, so this one this is still a very old school, like, not to say it is easy, but it's a problem that for whatever reason used to come up on textbooks, right? So if you study algo, you'll probably have come across this, but so we'll see how far I get from going from first principles, because I haven't seen this in a long time, except for I think there was a variation on this on a Q4 maybe a year and a half ago or 2 years ago, where like there's like a YIVO string like that. So I think it was like distinct non-empty subsequence with a non-YIVO substring or something like that, or subsequence, I forget. So that is a little bit tricky, but that's not so bad. So the hard part is kind of figuring out how the distinct part works, right? Because for example, you have n characters. Is always going to be 2 to the n for a number of subsequences. That's just how, like every character could be in and out. But then now you have to figure out the distinct part. I'm not gonna lie, I do not remember quite how to figure it out. But I don't remember the recurrence, and this is something that maybe I should, but let's kind of start, right? So I imagine I have an index, but what does that index mean, right? So let's say we have an A. What we want to do, or like, what are the duplicates, right? I mean, so also for these things, you can do it both ways. You could count the number of duplicates or whatever, and then subtract it from the total, or you could just count the number of distinct. I think this is actually one of my I used to be very good at this particular one, because more than 2 decades ago, this was something that I studied in uni, because I was in computational biology, and there was some stuff that dealt with a number of distinct subsequence stuff, with DNAs, but that was a long time ago. So I definitely could, but it's one of those things that it's so textbook you could cheat nowadays, where back then you couldn't really Google it that much. That's what I mean by cheating, by the way. But okay, so what is the recurrence here? And this may take a while, I'm not gonna lie, I don't remember quite how to do it. So let's say we have, okay, let's maybe go from first principles. So let's say now we have ABC. Let's say we have A. So okay, let's say we have all the A prefixes, right? So that means that we have A, using the first one with AB. Well, we just have regular A, AB, AB, AC, ABC, right? So there's 4, right? Okay. So, or if we don't use the A, what do we get, right? We get B, we get C, we get, oh, I guess this is I mean, yes, but this is, it's not useful because, it's just, like I said, 2 to the n. So we need something a little bit more awkward. So let's just say we have A, B, A, A, right? Something like this. Okay, so we have A, which let's say we take this A, right? Because there are really only two things, and we're trying to figure out the recurrence. And yeah. Okay, so then now we have A, we have AB, we have ABA, we have A. I don't know what's the best way to enumerate this. I guess we just do okay, let's just do it this way. This is awkward, right? I don't know. What is the best way to enumerate it? ABA, let's just do it this way then. And then AA, AAB, AABA, right? And then AB is not true, and neither is BA. So there's no one here, and then also AA is not true, right? So in this case, this is all the prefixes that start using the same A. What is the recurrence here, right? Well, I'm missing one actually. I think there's an A. Yeah. Well, maybe even missing more, to be honest. So this is going to be an actual solve, just because I remember the literature, but I don't remember how to attack this. I do have some ideas, so it's still whatever, but this is how it looks like if you, like 80% of if I haven't seen this before, pretty much, because it's so long ago. Okay, is this all there is? I think I'm missing some here as well, so I lied. So there's ABB, ABBA, ABA. No, this is duped. AB. I guess that's it. Maybe. I don't even know anymore, right? And then what is the idea? Can I take advantage of, repeated A's, right? Like one idea, which I don't know if it works, it's just an idea, is that we do the recursion on all the A stuff, and then we subtract out the stuff that has the next A. Does that work? The reasoning being, say that, let's say we have the A suffix, right? Because then now what we want to subtract out is all the, so can you subtract out just all the suffix A's? What I'm trying to do is that, okay, let's say we have some F of A, B, something like this. Well, what we want to do is subtract out something like F. I don't even know I could draw it quite right. But what we want to do is, let's say this A, and then, because let's say let's say we ignore the repeats for now, we know that if we do the function in a more natural way on the skipping ones, well, we have A, we have ABA, AB, we have ABA, we have AA, right? And all of these, of course, by definition, let's just look at the suffix here, right? By definition, and the suffix here are just going to be, empty. So this is nothing. We have a B, we have BA, and then we have an A, right? So that's just these without this A, right? And in that case, another way to think about it is that, let's say you want to add an A. Well, we can add the A from here, and we can add A from here, right? So that means that the first instinct would already contain all these things. So then if you subtract it from here, then you're deduping it. And this is going to have to, that's an idea. I don't know if this is going to end up being approved by AC a little bit. And then the second idea is also, the second thing I'm thinking of is, let's say you have this. Do you, like, it almost becomes like an inclusion-exclusion thing of like, okay, you have this A, you minus this A. Do we also minus this A from here? I know that this A minus this A, so then we have to like you know, like I said, like inclusion, exclusion, right? So, okay, I will give it a try. Like I said, I don't know how to do this off my head per se. So yeah, and I'm going to just skip the caching part for the teaching. I'm going to use the cache. We'll talk about it in a little bit, but I want to focus on the hard part, right? If you are struggling with dynamic programming problems, and I have a lot of videos where I try to do it in a way that is easier for teaching, so definitely, you know, focus on that one. But yeah. Yeah, okay. So then here we have go of index plus 1. That's just not using this letter. Plus, wait, is it? Well, it's something like this, because then both using and not using is the same. But then now we just want to subtract out something like, we want to subtract out all the other ones. And I don't know that this, like I said, this is me exploring. So yeah, so this is me going go index if s sub I is equal to index or s of index, and of course we actually want to start from index plus 1. Then is that an I or I plus 1? No, it's I plus 1 because you're assuming that you use it. Maybe, I don't know. Let's play around with this. Right. The beauty of Python is that you could actually write this like so quickly, you know. Oh, I forgot to. And it may be like -1 because we count empty strings or something. So yeah. Okay. Well, that's unfortunate that this is right actually, but because if they were both wrong and off by 1, then it's a little bit easier. But it may be that this is just, maybe I don't handle the empty string quite well. Or like the, yeah, let's try at least something funkier first. Right. If this is right, then it gives me confidence to think about this one a little bit. This is pretty slow. Shouldn't be that slow though. Okay, so this is not even close. Well, the two cases, where is this wrong? And this is just, wait, what? Oh yeah, well, why is this wrong? So, okay, let's at least debug this one. This one should be easier to debug, at least in logic. I mean, I know that I could just fix it by off by 1, but that's not why we're debugging, right? Where's the plus button? Oh, there it is. Let's see. Okay, so this is, well, I mean, that's fine. Well, that means that we're doubling up somewhere. Maybe this part of the logic is wrong, because my logic here is that, you know, we have two cases. One is not using it and one's using it, but there's clearly some weirdness about not using it. Okay, so let's trace this a little bit. Right, so we have 5, right? Let's start with 5. Let's actually have one that's 5, then why not? What do I think I get? Maybe this is I. Okay, now it's just more wrong. It's still very wrong, actually. And also, okay, well, because now you're using that one. Yeah, no, I mean, I think this logic is okay. But, well, I mean, obviously the logic isn't okay, but I just mean like conceptually. Okay, so let's say we have this, right? So at index is equal to 0. What do we have? Well, at index is equal to 4. That's just gonna, well, index is equal to 5, then this is just equals to 1. Index is equal to 4, then it returns 2 because it doubles up, which is it's wrong, but that's okay because that's where the -1 comes from, because it contains the empty string. I think so that dupes it. So I think in theory that's okay. So index is equal to 3 is where we are starting to get off the rails, because basically now you have an A, you go twice of this one, so now we have 4 is equal to 4 minus this one, so then it -1, so this is equals to 3, which is already wrong because it only has 2. Well, okay, no, actually this is still right, because for 2 things, again, we're adding an extra 1 because, you know, yeah, I'm not counting this quite yet, because it contains the empty string. So okay, so index is equal to 2, r is equal to, well, now it's 6 from the 3 times 2. And then we subtract 2, and then we subtract 1. So that's equal to 3 again. Now that's not consistent, even if it's right. I mean, yeah, that's not right. I actually don't know how this, unless I'm doing it wrong. Let's print it out real quick. I'll put it on this side. See if that works. Okay. Okay, so this is actually what we said it was, or what we have here, kind of. I mean, it doesn't print 5, but that's okay. So 2, 3, 3, and that's what I thought, that this is weird. And then, oh, okay, so we're getting a big number because this is 2. So do we? Does this fix it? I wasn't sure we needed to do it for every index or just the next index. Okay, wow. So that is enough to solve it, huh? Wow, that is because that was the thing that I wasn't sure about, whether, like, with, I know about the inclusion exclusion, but I wasn't sure whether that was going to keep going. And one thing that we can do here is noting that this is very expensive to kind of keep going, so we can actually just pre-calculate this. But let's give it a submit real quick, to be honest. Let's not prematurely optimize. I might get, oh, okay, well, did I mess up on the whatever? Because this should be the same. Oh, right, okay, fine. Yeah, I just, okay. Yeah. That's a silly mistake, but okay. I mean, there's some optimizations we can do here, but at the end of the day, you know, index can go from 0 to n, and this loop, so yeah, time complexity is equal to, you know, number of inputs times input per time, or time per input, whoops. And of course they're O of n inputs, O of n time each, so O of n squared, right? You could reduce this to log n, you can reduce this to O of 1, so we can do that as well. What's my submission time? Yeah, it's kind of terrible because this is n square as a result, right? Let's play around with optimizing this because we have time. Yeah, the reason why this works, and I was actually not sure about which way it was going to be honest, is, or like we need a double count, is because when you do the next one, the next character, then it already encompasses the stuff that you're already going to delete in the future, something like that. I don't know if I'm saying that right. So, but that's basically the idea. Okay, let's actually optimize this because we can. And then here, let's just say we have something like this. We have for I in range of n minus 1 minus 1. Right, so s of I is the character they're doing. So we have last of this is equal to I, right? Yeah, so that we update this, but we update this last, and then maybe we have a previous array is equal to none times n, and then basically you have, well, I guess technically it's not previous, it's next now, right? But I is equal to last of x of I if previous of I is, if s of I is in last, we do this, and then here, then now we can just do something like if previous of index is not none, then we do this, yeah, right, something like that. Let's give it a submit. Very easy optimization, right? And now we go to, you know, I forget where we were, but now we're much faster, 8%, 82%. I mean, now it's linear time, right? Because now this is just an O of 1 operation. So that means that this is O of 1, and then now we have linear time, linear space. I didn't explain this part very well, but what we're doing, if you kind of look at the old for loop, let me just, if you look at the old for loop, what you're doing is you're trying to find the next instance where, you know, given this index, your current character, you're just trying to find the next next index where they match, right? Where the characters appear, and so we just build up a table so that we can, I call it previous, maybe I should call it next, but yeah, it's just the next case where it shows up, and then we run it backwards so that we could keep track of it. Yeah, and this is of course linear space, and this is just O of 26 space or whatever. So yeah, so that's why this is linear time, linear space. That's pretty much it. I did solve this idea from scratch, which I'm really happy about. I'm actually surprised that it works. I thought there was something more complicated. Maybe it's been a while, because this is one of those problems I'm very happy to solve, even though I've solved this a couple of times, like decades ago. And the reason is because I think back in the day, and I'm not gonna lie, right? This is just me telling a story, and you know, you're here. Hopefully, this is an interesting story. Is that I probably learned a lot of dynamic programming through the same way that a lot of you at home have, right? You know, you just memorize certain patterns, and you know, kind of figure it out, and hopefully just make it a little bit better. And you know, back in those days, we didn't have Google, we didn't have YouTube. I mean, we had Google a little bit, but you couldn't Google for resources anyway, because no one created the websites that you could Google from, really. So a lot of it's from textbooks, and so this one, I think I probably is one of those problems that I just kind of memorized a little bit from 2 decades ago, and this time I feel proud that I actually was able to do it from scratch. I did have some inkling about this subtraction thing, so it wasn't totally from scratch, to be honest. But yeah, so hopefully I can, you know, solve similar problems easier in the future or something. Anyway, that's pretty much all I have for this one. So let me know what you think. Stay good, stay healthy, to good mental health. I'll see y'all later and take care. Bye bye.